This section, we are going to focus on rationalizing numerator, denominator, as well as dividing radical expressions. Rationalizing a denominator means write your expression in a way that way there's no more radical in the denominator. Rationalizing numerator means writing your expression in a way so that there's no more radical expression in the numerator. The technique used in this section is to multiply both top and bottom, which is your numerator and denominator, of the algebraic expression by a quantity that will make the radical in the denominator disappear whenever we want to rationalize the denominator. It's a norm in algebra that we don't leave a radical in the denominator. Then your answer is considered in the simplest form. So don't leave a square root, fourth root, third root, fifth root, any radical in the denominator. We will have to rationalize the denominator. Okay. So rationalizing the denominator with one term, multiply both numerator and denominator with the appropriate power of denominator so that denominator becomes a perfect power of radical. Let's see some examples. So here's the first example. I have 1 over square root of 5. My goal is to make the root 5 a perfect square. So what can I do here so that I can get no more square root in the denominator? Well, if I have square root of 25 in the denominator, then I should be good. So, or you can also think about, because it's a square root, how many 5s do you need to have inside to be able to pull them out of the radical? Well, you need to have 2 5s inside the radical. So you already have 1 5, and I'm multiplying with another 5, both numerator and denominator. If you multiply both numerator and denominator with the same thing, you're not really changing the value of fraction. You're technically multiplying by 1 because root 5 divided by root 5 is 1. So this turns out to be root 5 divided by root 5 times 5. Because I have 2 5s inside the square root, I can pull 1 5 out in the denominator. You can also think of it that this is square root of 25, and square root of 25 is just 5. Okay, next we have root 30 over root 32. I'm going to try to first simplify the root 32. I'm not going to go ahead and multiply numerator and denominator with root 32. I'm going to simplify the root 32. Okay, again, remember, read the directions. We are rationalizing the denominator here. We don't want any square root in the denominator. Square root, cube root, fourth root, third root, nothing in the denominator. No radicals in the denominator. So 32 is 2 times 2 times 2 times 2 times 2. Now let's go ahead and simplify it first. For every pair of 2 2's inside, 1 2 can be pulled outside. So 2 times 2 outside would be 4, and there's a root 2 inside. Now for me to be able to get this 2 out of the radical in the denominator, I need to multiply both numerator and denominator with a square root of 2. Because I want to have two 2's inside the square root, so I can pull it out. The numerator becomes square root of 6. Because your indices are same, we can multiply the radicands and write as a single radical. And the denominator becomes 4 times root 2 times 2, which can be further simplified to square root of 6 divided by 4 times 2, which is root 6 divided by 8. And that's our simplest form of this radical. Number 3, we have 4 over 3 root 5x. Okay, for me to be able to pull something out of this, 3 is just the coefficient in the front. So 3 is just sitting in the front. So we will multiply both numerator and denominator with a square root of 5x, because I need to have 2 5's and 2 x's inside the square root so that they both come out and there's nothing left inside the radical anymore. That's the goal when you're rationalizing. You don't want anything in the denominator that's a radical. Any radical, no radical should be left in the denominator. That's what rationalizing the denominator means. If you were to rationalize the numerator, it would be something similar. You just don't want to have any more radicals in the numerator then. So the denominator becomes 3 times root 5x times root 5x. Now 4 root 5x over 3 times 5x, because 1 5 comes out and 1x comes out of the square root. So this is 15x. because we can multiply them together. And that's our final answer, end product here. More examples. Here's number 4. 5 over cube root of 3y squared. Okay, 5 over cube root of 3y squared. So here I'm dealing with the cube root, so I got to be extra careful. I have 5 over cube root of 3y squared. So I'm just going to write y squared as y times y. In order for me to have no more radical in the denominator, I need to have total 3 3's inside the cube root, then I can pull one out. Total 3 y's inside the cube root, then I can pull one out. This is the harder step where you have to think about what should you multiply both numerator and denominator with. Well, in this case, I'm going to multiply with 9, or I can say 3 times 3. I need to bring 2 more 3's and 1 more y. 2 more 3's and 1 more y, that will do the job. So this leaves me with 5 times cube root of 9y. And in the denominator, I have a cube root of, there's already a 3. I'm writing it as a single expression in the denominator. And y times y times y. So I can pull out cube root of 9y over 3y. And that's what we would be left with. Okay, so be extra careful, look carefully. Why did I choose to multiply with cube root of 9y? Because I wanted to have a perfect cube inside. Okay, if I had a square root in the denominator, then I want perfect square inside. So I know it's a cube root, so I need to have total 3 3's inside to be able to pull one out. I already had 1 3, and I chose to bring 2 more 3's. And I already had 2 y's, and I chose to bring 1 more y. Let's look at example number 5. For example number 5, I'm dealing with a cube root again, 5 over cube root of 4x squared. Okay, so I want to have a perfect cube inside. I'm going to write it slightly differently because I'm trying to think about how can I pull, if there's anything I can pull out of this cube root first of all. If not, then I need to think about what should I multiply the numerator and denominator with that we have a perfect cube inside. Why do we want perfect cube? Because I'm dealing with a cube root. So I need to have 3 2's inside of a cube root to be able to pull a 2 out. So that means I need to bring 1 more 2 here and 1 more x. So I'm going to multiply both numerator and denominator with a cube root of 2x. Okay, so we have 5 cube root of 2x divided by, we have a cube root with 3 2's and 3 x's inside. And that turns out to be 5 cube root of 2x, the 3's in the pocket, and divided by 2x. Okay, that's it for this one. Let's check out number 6 now. For number 6, I have a, first of all, I'm going to write the numerator and denominator separately. And then I'm going to go ahead and try to simplify. Because I see cube root of 8 is 2. That I can pull out right away. So cube root of 8 is 2. I pulled out of the cube root. Now I need to think about, I don't want to have a radical in the denominator. So what do I multiply numerator and denominator with so that I have no more radicals in the denominator? So I need to have total 3 x's inside the cube root. Only then I can pull them out. I already have 1, so I'm bringing 2 more in. So there's total 3 x's in the cube root, and I can pull an x out. That leaves me with no more radical in the denominator. So on the numerator, both of them have the same indices. Both are cube roots. So I have 5x squared in the numerator, and there's already a coefficient 2 in the front. And x is what I would be left with because I have a cube root of x to the 3rd power. 3 x's inside the cube root. Okay, let's check out number 7. So for number 7, I have cube root of 5x squared in the denominator. Is there anything I can pull out from here right away? Doesn't look like. So I'm going to be multiplying both numerator and denominator with how many 5's do I need to have to be able to pull 1 out of the cube root? Well, I need to have total 3 5's. I already have 1 5, so I'm going to bring 2 more, 5 times 5. And there's already two x's in here. I need to have one more x. So I'm going to multiply numerator and denominator with one more x as well. Turns out to be in the numerator, I have 3 times cube root of 25x divided by cube root of 5 times 5 times 5 times x times x times x. 3 times cube root of 25x, cube root of 25x divided by 5x. And that's our final end product here. Okay, well, I don't have any radical in the denominator, and that was the goal. Okay, let's check out number 8. Number 8, we have 5 over 5th root of 16x to the third. Well, you got to be clever here. First of all, let us think about how many. Let me break 16 really quick. 5th root of 16 is 2 times 2 times 2 times 2. So 2 to the 4th power is 16. Or if you want, you can write in the expanded form and say 2, 2, 2, 2, 2, 1, 2, 3, 4. I put an extra one there. That has to go away. And there's 3 x's. Okay. Now you're dealing with the cube root. I'm sorry, 5th root. We're dealing with the 5th root. The number in the pocket is 5. And we have 4 2's and 3 x's. What do I multiply numerator and denominator with so that I can pull something out of the radical? Well, I do need to multiply numerator and denominator with the 5th root of what? 5th root, I already have 4 2's. I want to have one more 2. And I already have 3 x's, so I want to have 2 more x's. So 5th root of 2x squared is what I will be multiplying numerator and denominator with. This leaves me with 5 times 5th root of 2x squared in the numerator. In the denominator, I have a 5th root of 5 2's inside and 5 x's inside. So that is going to leave me with 5 5th root of 2x squared divided by 2x. Okay. That's going to be our end product here. Number 9, we have a cube root in the numerator, cube root in the denominator. So let's again rewrite it and see what exactly I should be. When you're rationalizing the denominator, we don't really care for what's in the numerator so much. We just think about how can I get rid of the radical from the denominator. So it's a cube root. 4 means 2 times 2. And y to the 4th power, so 4y's inside. Let's go ahead and simplify it really quick. Is there anything we can pull out? There's 4y's. For each group of 3y's inside, 1y can be pulled out. We have cube root of 2 times y. Since it's a cube root, I need to have, because it's a cube root, I need 3 groups of 3 things inside to be able to pull one out, right? So groups of 3 things inside to be able to pull one out. This is going to be, so I'm going to multiply both top and bottom here, both numerator and denominator, with cube root of, I need one more 2 and 2 more y's. Okay, 1, 2, and 2 y's. 2 y's can be written as y times y or y squared. So both numerators have the same index 3 and 3. We can multiply them and make it a 1 cube root, which turns out to be 6xy squared. And the denominator turns out to be, there's already a y sitting out in the front, and I can pull a 2 and a y from inside. So cube root of 6xy squared over 2y squared. And that's our end product final step. In all these examples, we rationalize the denominator when we had a monomial in the denominator. We had our denominator was a single term. We had a monomial in the denominator. Now, next few examples, we're going to look at the examples where denominator is a binomial. Denominator will be binomial, means it would be 2 terms. It would be, denominator would be 2 terms. So in that case, we will multiply top and bottom, which is numerator and denominator, by the conjugate of denominator so that the denominator becomes a difference of squares. So let's think about what is a conjugate. So conjugate of a plus b is a minus b. Okay, what would be the conjugate of negative minus a minus b? That would be minus a plus b. So you only change the middle sign, okay? Here, well, I shouldn't say number 1 and letter A. Let's just delete number 1 here. What's the conjugate of 2 plus root 3? Would be 2 minus root 3. What's the conjugate of negative 2 minus root 5? Would be negative 2 plus root 5. So only change the middle sign, okay? Only change the middle sign. And that's how we find the conjugate. So rationalize the denominator. Now in this case, don't multiply numerator and denominator with what we have in the denominator. That's not going to do the job. You can give it a try. You will still have the radical left in the denominator if you do. So if your denominator is a binomial, always multiply both numerator and denominator with the conjugate. So conjugate for 6 minus root 3 would be 6 plus root 3. Numerator becomes 11 times 6 plus root 3. Denominator becomes difference of squares. If you recall, a plus b times a minus b is a squared minus b squared, or you can FOIL. So whatever works for you, you can do either one of them. I'm going to use the difference of squares, a squared minus b squared. In the numerator, 11 times 6 plus root 3 over 36 minus 3, which is 33. 11 times 6 plus root 3 over 33. And we can simplify, cancel. Because 11 is in the factored form and 33 is also written isolated, we can cancel common factors. So 3 times 6 plus root 3, which is 18 plus 3 root 3 is our final end product here. Okay. Oh no, that's not correct. I made a small mistake here. Actually, a big mistake, I would say. It's not a small mistake. So when I divide 11 and 33, we had 11 here, 33 here. We have 3 in the denominator. 6 plus root 3 divided by 3 is what we're left with. That's our final answer. Okay. Another example of rationalizing a denominator. Example number 2. What should I multiply numerator and denominator with? Well, in this case, I'm going to multiply 3 minus root 5, 3 minus root 5. Okay, in the numerator, root 3 times 3 minus root 5 over 3 squared minus root 5 squared. Turns out to be, I can distribute 3 root 3 minus root 15 divided by 9 minus 5. So 3 root 3 minus root 15 divided by 9 minus 5 is 4. So that's our final answer. If you prefer, you can write them as 2 separate fractions. It's okay to do that. Or I personally prefer a single fraction. And there's nothing that I can cancel between numerators and denominators now, so we'll just stop at this point. Okay. Next, we will look at example number 4. We have root 5 minus 2 over root 3 minus root 5. This one has a binomial in the numerator, binomial in the denominator, and we have radicals involved. So again, read the directions. We are rationalizing the denominator, okay? We're trying to get rid of the square roots from the denominator. But if we are rationalizing the numerator, it would be the same process, similar process, right? We would just think about conjugate of numerator and multiply both numerator and denominator with conjugate of numerator in that case. So here we have root 5 minus 2 over root 3 minus root 5. Let's go ahead and multiply numerator and denominator with the conjugate of denominator. Okay, so I do have binomial on the top, binomial on the bottom. So I'm going to have to do distributive property in the numerator. So I'm going to write it here as root 5 minus 2 times root 3 plus root 5. And the denominator would be root 3 squared minus root 5 squared. Let's go ahead and FOIL the numerator. It's going to be root 15 plus root 25 minus 2 root 3 minus 2 root 5 over 3 minus 5. Let's see, what does that leave me with? So this is root 15 cannot be simplified anymore, plus 5 minus 2 root 3 minus 2 root 5 divided by 3 minus 5 is negative 2. So what we can do is we can put that negative in the middle, front of the fraction, and make it go away from the front of the 2. And that's going to be our final answer and product here in this case. Let's look at one or two more examples. Actually, I think I'll pick number 7. Number 7, so we're going to look at number 7 now. Again, we are still rationalizing the denominator, so I'll have to multiply both numerator and denominator with the conjugate of denominator. Okay, conjugate of denominator. So I'm going to multiply with 4, oh no, conjugate of denominator. That would be, so again, rationalize the denominator. We're still doing rationalize the denominator. I'll also do an example of rationalizing the numerator in a minute. So 2 root 5 plus root 2, 2 root 5 plus root 2. Again, a binomial, so we'll have to do some simplification, okay? 2 root 5 minus root 2, 2 root 5 plus root 2. So how do I, on the denominator, I'm going to have 2 root 5 squared, which is my a squared, minus root 2 squared, which is my b squared. And the numerator, I have to do foiling, first, outer, inner, last. So that's 8 root 25 plus 4 root 10 plus 2 root 10 plus root 4. Simplified further, 8 times 5 plus 6 root 10, like terms I can combine, plus 2 over, so when you do 2 root 5 squared, that means you are doing 2 root 5 times 2 root 5, which turns out to be 4 times 5. 4 times square root of 25, which is 4 times 5, and that's going to be 20. So 20 minus 4. Simplification required, 8 times 5 is 40, plus 6 root 10 plus 2 over 20 minus 4 is 16. So 42 plus 6 root 10 over 16. Now I'm not going to stop here. I need to see if I can simplify it further, if I can pull something out. Looks like I could pull a 2 out from here. If I pull a 2 out from the numerator, 2 times 21 is 42. 2 times 3 is 6. And then I have 16 in the denominator. Now I can simplify a little more. Final answer would be 21 plus 3 root 10 over 8. Okay. One last example where I'm going to rationalize the numerator, just because we haven't seen any example, rationalize the numerator. Okay. Directions can say divide. For rationalizing a denominator, where directions can say divide, or you can say rationalize the denominator. Okay. Or it can say simplify. We just know whenever it says simplify, we cannot leave a radical in the denominator. Now for rationalizing the numerator, we will multiply both numerator and denominator with the conjugate of the numerator. Conjugate of numerator would be, here's my numerator, the conjugate would be root 11 plus root 5. Root 11 plus root 5. Okay. So let's go ahead and FOIL in the numerator, FOIL the denominator. So numerator comes out to be, I'm using the difference of squares. And in the denominator, I'm going to be doing FOILing. Root 11 times root 11 is 11 plus root 55 plus root 55 plus root 5 times root 5 is 5. Yep. So that leaves me with 11 minus 5 in the numerator, and 11 plus 5 is 16 plus 2 root 55. 11 minus 5 is 6 over 16 plus 2 root 55. Now we can pull out a 2 from the denominator and cancel with the 6. Now this can be written as 3 over 8 plus root 55. And that's our final answer in this case, and we rationalized the numerator. We don't have any more radicals left in the numerator here, and that was the goal.